Hey everyone, so for today's lesson, we're going to extend what we already know about functions and we're going to look at tables in a different way. So normally with functions, we were deciding whether the x's repeat, whether there's one output for every input, and we were able to decide whether it was a function, whether it was linear or not. But today we're going to look at the tables themselves and see if we can come up with a function rule based on our inputs and outputs. So here's your title, Determining a Function Equation. And just a couple of reminders. We have our input, which goes into our function machine. That's our domain in mathematical terms, and it stands for all of the x values that we would plug into our linear equation format, which is typically y equals mx plus b. Then we have our output, which we also call our range, and those are the y values. So that's what comes out of the machine once we put in our x values and compute the actual function. And then here's just a drawing of our function machine. Beautiful, as always. We can see that what we put in terms of x, something happens to it in the machine, and once whatever happens to x is done, we get a new output that comes out. So an example of that is if I put the input 2, if that's part of my domain, I plug that in to, let's say our function is 3x plus 4. So once I plug that in, it becomes 3 times 2 plus 4, and my output then would be 10, or in this case, y equals 10, since we're dealing with linear equations, slope-intercept form. And just a reminder, this is our slope-intercept form. So let's look at a couple equations then of what we could, couple examples, I should say, of tables that we could decide the function rule for. So here's our first one, and I can see that I have a domain of 1, 2, 3, 4, 5. I have a range or outputs 2, 3, 4, 5, 6, and from this I need to decide a function rule. So before, what we did was we found the slope, and then we used it to find the y-intercept. In this case, I don't have x equals 0, so I don't have a y value to match for the y-intercept, so I would actually have to calculate it. But we can also look at patterns to decide function rules. So when I put in 1, I get 2 out. So in my head, I'm thinking, what are some ways that I could turn 1 into 2 inside that function machine? I could double it, so I could, I'll put this as possible because it might not be true for all, but possible could be if I take x and I multiply it by 2. Because if I did 2 times 1, I would get 2. 2 times 2, though, doesn't give me 3, and 2 times 3, so on, doesn't give me 4. So actually this is not possible. Another way that I could turn 1 into 2 is I could add 1 to it. So I could take my x value and I could add 1. And again, if I plug in my x values or my domain here, 1 plus 1 gives me 2. That works. 2 plus 1 gives me 3. That works. 3 plus 1 is 4. It works for all of them. So actually, this would be my function rule. But we're not done. This is an expression here. We need the equation. So just like in slope-intercept form, y, or my output, equals my input plus 1 added to it each time. All right. Let's look at this one on the bottom. Example 2. I wrote function, should say function rule, but is it a function? Yes, just to review, we can look at this. None of my x's repeat, they are all paired with y's, so this would in fact be a function. Let's figure out the rule. So again, possibilities. Well, in the last one, all I was doing was adding, so let's try that out. If I take x, which is 2, how do I get 5? Well, it would have to be x or 2 plus 3. So let's see if that works out. 2 plus 3 is 5. 4 plus 3 is not 9 though. So as soon as I have one that doesn't work for the rule, it cannot possibly be the rule. So this wouldn't be it. I can't multiply 2 by anything to get 5, but I could do, let's try, if I did 2 times 3, or x times 3, that gives me 6, and then I would have to subtract 1 from that to get 5, because that equals 5. So let's see if that works for the other ones. 4 times 3 is 12, and then 12 minus 1 is 11, so no, that one doesn't work either. Let's try something smaller. How about, let's do times 2. So x times 2, that would be 2 times 2, which gives me 4. I'd have to add 1, so that gives me 5. 2 times 2, 4 plus 1 is 5. Yep, that works. 4 times 2, 8 plus 1, 9. 6 times 2, 12 plus 1 is 13. 8 times 2 plus 1 is 8 times 2 is 16 plus 1 is 17. So yep, this one works out. Let's put it into correct form. Output equals, we would write it as 2x plus 1. And if I were looking at my rate of change here, I could see that it's 4 over 2. 4 over 2. So that matches 2x. And then adding the 1, we would find our y-intercept. So going 2 down from this would be my 0, and 4 down would actually be 1. So, yep, it works out. All right, tonight. Let's write this one down under our summary, along with the notes you've already taken. So you can pause, copy this down, and you are to come up with a function rule for this. Now I made it trickier, yes, because there are negatives. So just remember, the larger the negative number is, the smaller the value of that number is. Be careful with that when you're adding versus subtracting. And then in addition, to share when you come in tomorrow, your question portion is make up your own table to share with your group. So it shouldn't be one that we've already done. It should not be a rule that we've already done. Make sure you plug in your values, whether you want to use a function machine or simply just the equation, and check to make sure that they actually work out. And be ready to go tomorrow. See you then. Bye, guys.